In number 5, we are asked to use the area model to write an expression in simplest form for b of x. Notice that b of x is not in the table. It is because we are asked to create an expression for b of x using these functions here. So m of x is right here, and t of x is right here. So we'll write here b of x is equal to m of x. We can put 2x plus 1 times tx is x minus 5. Okay, now, so we want to write the expression using area model. When we are thinking of area model, we have to use the algebra tiles. So let's review algebra tiles again. Algebra tiles is made up of 3 kinds of tiles. One of the tiles is a big square, and this square has a length of x. Let's put here x, and the width is also x. Therefore, the area of this square is x squared. Length times the width is equal to x squared. So length is x, width is x, area is length times the width, therefore x squared. Another tile is a rectangle. So there's a rectangular tile. Now the width of the rectangle is the same as the square. So this width is also x, and the length is 1. Therefore, the area of this rectangle is 1 times x, or simply x. Okay, so again, the length of this rectangle is 1, the width is x, therefore the area is x. Now, the last tile is a very small square, and here the length is 1 and the width is 1. So notice that the length and the width is the same as the width, or rather the length of this rectangle tile here. So that means this will fit, this is going to fit on that side. Okay, so to use the area model, we are going to use these tiles. Oh, by the way, the area of this square tile here is 1. 1 times 1 is 1. And that's why we call this the unit tile. So again, the tiles are the x squared tile, the x tile, and the unit tile. The x squared tile has length x and width x. The x tile has a length of 1 and width of x. And the unit tile has length 1 and width 1. So now we need to draw rectangles so that the length is 2x plus 1. Okay. So we're going to use the algebra tiles to create a rectangle where the length is 2x plus 1 and the width is x minus 5. So let's start with the length first. So in order to make a rectangle where the length is 2x plus 1, I can use the big square tile. So if I draw one big square tile, I know that the length is x and the width is x. So I already have, right now I have a rectangle where the length is x and the width is x. But I need my rectangle to have a length of 2x plus 1. So I need another x to make up the 2x. So that means I need another square tile. So now I have a new rectangle where the length is, this is x, from here to here is x, and from here to here is also x. Therefore, the length is now 2x, and the width is still x. But we have to remember that the length of b of x should be 2x plus 1. So that means I need to extend the length by 1. And so I'm going to need an x tile because the length of the x tile is 1. So I'll have that 1 there. And if I put here the rectangle, then I still have a rectangle. The length is 2x plus 1 and the width is x. Okay, so we have established a length of 2x plus 1. Now we just need to make sure that the width is x minus 5. But right now the width is x. So what we need to do is take away 5 from the width. So in order to do that, okay, let me just erase this little thing here. All right. So in order to do that, I need to cut off. Okay, I want color. What happened to my color? Okay, there. Okay, so I need to cut off 5 units from the width. So that means I'm going to go inside. So let's say this is 1 unit. So from the corner to this is 1 unit. So if I cut this out, okay, so that means I actually cut out this part here. That's one X tile. And here's another X tile. So I cut out 2 X tiles. And then this part here is a unit tile. So I cut out 2 X tiles and a unit tile. Okay, so but I need to take away 5. So I'm going to take out another one. Okay, so I'm going to take out another one here. So that means I'm taking out 4 X tiles and 2 unit tiles. So if I continue taking away from the width, okay, so this is the third unit I'm taking away from the width. So now this is X minus 3, but I need X minus 5, so 2 more. So take this out and take this out. Okay, it's kind of hard to draw straight lines. So now we have a smaller rectangle, but I know that the length of this rectangle is 2x plus 1, and the width is now x, but I took away 5. So now it's x minus 5. So this smaller rectangle is now representing a rectangle where the length is 2x plus 1 and the width is x minus 5. So now what's the area of this remaining rectangle? Now, to calculate the area of the remaining rectangle, we have to think first of what we have in the beginning. In the beginning, we have 2 big x squared tiles plus 1 x tile. So we can write that down. We have 2 x squared tiles plus 1 x tile. And then we started cutting off. So that means we have to subtract. And we subtracted 1, 2, 3, 4, 5, and then 5 in here too. So that means we subtracted 10 x tiles. So minus 10x. And we also subtracted these 5 units. So minus 5. Therefore, if we clean this up, b of x is equal to 2x squared minus 9x minus 5. This is the expression that we're looking for b of x. Now let's do number 6. In number 6, you're asked to use a generic rectangle to write an expression for b of x. So the same thing, we're looking for b of x. It is defined the same way, but we are going to use a different strategy. We're going to use a generic rectangle, and that is when we do this. We'll just draw an arbitrary rectangle, and we will label the length as 2x plus 1 and the width as x minus 5. And then we find the area of each part of the rectangle. So x times 2x is 2x squared, x times 1 is x, negative 5 times 2x is negative 10x, and negative 5 times 1 is negative 5. Therefore, b of x is equal to 2x squared, negative 10x plus x is negative 9x, and then minus 5. So obviously, we're supposed to get the same answer, but here we are showing two different ways of finding b of x.